These are just a few detectors. I'm going to explain these. You don't really need to know them in detail. A Geiger-Müller tube, this is the one we used in the lab. Photographic film, a spark counter, we didn't use that in the lab, and a cloud chamber. I showed that to you in the lab as well. So just a brief explanation. Whenever you have a photographic film, this is what the radiologists would use when they're working with radiation, or radiographers in an X-ray department. They have a piece of film. When the radiation hits it, it darkens. Can the photographic film tell you what type of radiation that is incident upon it? No, it can't, but it can tell you how much radiation it received, because the more radiation it receives, the darker it will be. What can this be used for? It can be used in radiation badges to record the exposure of workers to radiation. Different types of windows then can be used, and these can detect different types of radiation, so that it is possible to detect the type of radiation that's falling upon it. The second one is called a Geiger-Müller tube. Again, you don't need to know details of this. If you just write down that you're using a detector, that's absolutely fine. The detector is a metal tube. It's filled with argon gas. The tube has a thin wire down the middle of it and a voltage between the wire and the casing. So this would be your other plates, which would be making that voltage between this and here. It's good for detecting alpha and beta, because when alpha and beta enter the tube, they ionize the argon gas in the middle. When radioactivity enters the tube, it ionizes the gas in the tube. This produces a pulse of current, which is detected by this middle part here, and it's passed to the counter and it counts in. So really that's the Geiger-Müller tube operates on an ionizing effect when the radiation enters the argon gas, and therefore it's not very good for detecting gamma radiation. A spark detector. A spark detector consists of a high voltage supply and a metal grid and a metal strip up here. Sorry, this is a metal grid here and this is a metal strip. A high voltage is applied between the two of them, but that is normally not a complete circuit because there's nothing to complete these two here. But whenever radiation enters it, it causes a spark to jump across from the grid, and then there'll be a detector somewhere. I think these are an ammeter or a voltmeter somewhere, which would detect that there has been a large increase. So when ionizing radiation is placed close to the detector, there is a marked increase in the amount of sparking. Which type of radiation would be detected the best? And of course the answer again is alpha, and it's most ionizing. So every so often, because it's high voltage, a spark will jump across naturally, but if you have radiation present there, then you get far more sparks jumping across, and that detects it. And again, because gamma is most ionizing, it will detect gamma the best. Sorry, alpha is most ionizing, it will detect alpha the best. The last one again is a cloud chamber, and you saw this. A cloud chamber shows the actual paths of ionizing particles. They rely on ionization. The cloud chamber is cooled, so down at the bottom here we generally would put a layer of ice or something, and then supersaturated with alcohol, so there's a layer of alcohol down here. If an ion is formed as a result of radiation passing into the cloud chamber, a droplet of condensation appears. So we could see these tracks when we looked into it. It's best for alpha radiation, as alpha is the most ionizing, then beta, which shows faint traces, but cloud chambers are not as good for gamma, as gamma is only very weakly ionizing. So generally we would have used this to look at alpha radiation, and you'd have seen all these kind of tracks in the alcohol vapour when you look in.